Okay, so members, we are going to see how do we determine the nature of turning points using the second derivative test, but please don't forget to subscribe to the channel. Now, we have three turning points. We have the maximum point where we have that it's maximum but it's maximum because the gradient here, the gradient is positive, 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 then it becomes a negative downwards. Still, this one is minimum because when you decrease, it first decrease, then it's negative, then it increases to get positive, positive, positive. This one will give us always a minimum point, or what we call a minimum. Then the point of inflection, if it decreases, after this it will still decrease. Or if it increases, it also increases after the point. So it's neither maximum nor minimum. If it's neither maximum nor minimum, it becomes a point of inflection. Also, what we have to get is a turning points, or is the first derivative is equal to 0. So the second time test says, if you differentiate the function the second time and you substitute the value of x at that point from the turning point and it's a positive, then that value is giving you a minimum. If you substitute the value after the second derivative and you get a negative, it means that value is giving you a maximum. Then if it's equal to 0, it means that that's the point of inflection. Look at this. Let us determine the nature of these turning points. So from here, I first get the first derivative. So my y, the x will be, this will be 2x minus 6. If we differentiate that. Now to get a turning point, I equate the first derivative to 0. So at turning points, it's that our dy, the x is always equal to 0. So equating this to 0, I have 2x minus 6 equal to 0. From here, I start my x is equal to 3. After getting the value of x, you come and get the value of y. From there, I start my y will be, if you substitute here, you have now 3 squared minus 6 into 3, then plus 4. And so the value you get here is negative 5. So putting it here now, our point is 3, comma, this will be 9, negative 5. So now we want to know, is this value of x giving, is this point minima or maxima? We use the second derivative test. So if I differentiate this now, the second time, so that I have now this squared y, the x squared, so that is going to give me now a 2. If I differentiate this, I get 2. And so this 2 is now greater than 0. It's greater than 0, we say, or is this bad point now is going to be a minima. So that's how we use the second derivative test. When I come to this, it's that now I get my dy, the x, which will be now, I'll be adding now, this will be now negative 2 minus 2x, if you differentiate that. But we know that the turning point, or is our dy, is 0. So equating this to 0, I have negative 2 minus 2x equal to 0. From there, so my x will be a negative 1. After getting the value of x, you come and get the value of y because it has to be a point. So my y now will be 7 minus 2 into negative 1, then minus negative 1 squared. This will be positive 2 plus 7, that's 9, minus 1, that will be 8. So my y is 8. So point is negative 1, the x value, then 8. Now I want to know, is it maxima or minima? I get the second derivative. From here, my second derivative is that now my d squared y, the x squared, will be now, when you differentiate this is 0, this will be a negative 2, which is less than 0, meaning that now this point is going to be a maxima. Why? Because this one is less than 0. Say that if the second derivative of that function is less than 0, it means if it's negative. Because it's negative, now means that this point is going to be a maximum. When I come to this still, I first differentiate. So I'll be having now equaling to minus 12x squared. You know that at turning point, the y, the x is equal to 0. Mean that now my 4x cubed minus 12x squared is equal to 0. So from here, it's that now 4x squared is common. I have x minus 3 equal to 0. So when I put this to 0, either my x is 0 or my x is 3. So now this one is giving me two values of x. It means that it has two turning points. So when I substitute here the corresponding value, is that my y will be, when I put here, I'll be having now 0, 4, then minus 4 into 0 cubed. So y will be also 0. So 0.00, I don't know its nature. When I substitute now, when x is 3, I want to know the value of y there. My y will be now 3 power 4 minus 4 into 3. And so this would be, this is 81 minus 1 over which is negative 27. The point we have here is 3 comma negative 27. Now you want to know, is this point maxima, minima, or point of inflection? Now you come and you get the second derivative from here. So now my second derivative there is going to be now this squared y, the x squared. If I differentiate this the second time, I'll be having now 12x, then minus, this will be giving me 24x. Now here so we have 24x, this one is 12x squared, this is 24x. Now, so that now here I have the values of x. It means that now I substitute the values of x to determine. When I put here now, when I put here, this would be 12, this would be, when I put now here, the value of x is 0. Now, when x is 0, so that now my b squared y, the x squared will be, when I put here 0, it will be 0, and this will be 0, it will be 0. Because it's 0, it means that now this point 0, comma 0 is, if it's 0, it becomes a point of inflection. Now, when I come now, I substitute in when x is equal to 3. When x is equal to 3, now I'm substituting here, minus square y, the x squared will be, when I put here 3, I have 4 into 3, square, then minus 24 into 3. Now it's like the value I'm going to get easy. 9, we get 9 times 12. 9 times 12. Then minus into, so that I get 36. And 36 is greater than 0 to mean that it's positive. Meaning that now the point with this x value, which is 3 comma negative 27, because it's positive, it's going to give me now a minima. So remember, that's how we use now. If after the second derivative we made with the x, that's how we determine those. We just get the value of x and substitute in this function. So please try out this number 4. Don't forget to subscribe. I wish you the best. Now we are going to see in the next video how do we use the table.